Good afternoon and welcome. Friday the 24th of July. Our session today is entitled How Blockchain Can Help Deliver Digital Twins. For those of you regulars that are on the call today, be very familiar with how this runs. We have a number of people from around the world today, from India, Germany, Argentina, Brazil, and so on. A lot more from the varied countries than we normally have. Obviously, a big attraction. Ian, who normally joins us with these sessions, is not able to make it today, so I'm all on my own, all on my Jack Jones. So we have been running these sessions successfully now since the lockdown began. We've been doing them weekly, and as time's progressed, we have had a number of very interesting sessions, delivering everything from project controls to today, well, digital twins and blockchain. What I will say is, for those that are unfamiliar with Commit, we are a collaboration platform. Let me just click onto the next slide. We're a collaboration platform that has been around since 2003. We were originally a DTI funded project. We work with our members, which consist of owners, operators, construction companies, software vendors, and academia. And we do get involved with projects, demonstration projects, and we have successfully bid for and delivered some projects which were government funded. The latest of which was just recently, where we bid for a COVID-19 application development, and we were very successful with one of our members, and we're currently working on the delivery timeline for that now. As I say, we get involved and we collaborate with our members. We have had some successful projects in the past, which were, well, ultimately delivered and are now thriving businesses in their own right. As is customary, but I've left these out recently, but I thought it was appropriate we do a safety moment today. So, did you know there's a lot more to wearing a safety mask than just wearing it? Okay. The main thing I want to get across here is, and as it says on item number 7, don't go commando, wear your mask. I think the rule from today, the 24th, is to actually wear it when you go shopping. We haven't had to do this up to now, but it makes sense. So that's our safety moment for today. Thanks very much for listening to that one. Okay, I want to share with you the interaction and asking questions, and I have got a number of things to go through here. You'll see the control panel on the right hand side. If you don't want to see that, just minimize it with the red arrow on the top. You have any questions, raise your hand or type them in the questions box at the bottom. We'll get to them at the end. There is an opportunity, if we don't answer all the questions, to join the session after the hour's up. We've had a number of requests in the past where people would like to continue the conversation. Well, we have an opportunity to do that. It has been quite useful in the past sessions and the recent sessions where we've had far too many questions to answer in the time that we had the first hour. So please stay on if you can. We also have some poll questions, which I'm going to do next. And for the first time, we're going to run a survey. I want to survey members' thoughts and ideas on timing, day of the week and time of the day. As a number of people have been unfurloughed and back to work, some people are now unable to make the Friday afternoon. So I'm just asking the question, what would be the best time for people to attend the webinars in the future? We are rolling them out to every 2 weeks, but I'll get to that near the end, as opposed to the weekly sessions that we've had. So the Commit to Productivity is something that it's an initiative that we started in Commit some time ago. We were due to roll the thing out in March, but of course things happened, as we all know, and any face-to-face meetings didn't happen. We've done some things virtually, but it asks the question, this initiative, what does productivity mean to you? Do you have the means to improve it? What else is out there in other industries, businesses and organizations? How can it help you, help us, help others? Please do get in touch, as quite a few have, and let's help create some enablement and enable for improvement and opportunity to develop where we work. These are the areas that we've looked at. The ones that highlighted are the ones that we're going to touch on a little bit today. I won't say too much more about that, as Stephen will take us through the session. Excuse me. I'd like to say thank you very much for our supporters, the sponsors rather, O2 Business and Rebin. Without those two organisations together, we couldn't actually deliver these sessions. So we're delighted to have them as sponsors. Thank you. Excuse me. So the main session today is how blockchain can help deliver digital twins. One day our buildings and infrastructure will be self-optimising in near real time to maximise performance and whole life cost. Highly tuned integrated systems that basically hum like a finely tuned Formula One race car. I won't say any more because I'll be stealing Stephen's thunder. After the session, we've got the panelists that we bring in. So we've got Gavin, David, and Michele, as well as Stephen, the main presenter. I won't say any more at the moment, but yeah, we've got an esteemed lineup today with quite a combined number of years of experience in this particular area. Okay, poll questions. I want to just bring in two poll questions that we've got. I normally say there's no curveballs, but today there is. The first one I've got here, excuse me, the first one I've got here is, okay, can everybody see the screen? Should be able to see that now. If you could have one of these superpowers, which one would you choose? You should be able to vote on that now. Interesting. Just give that a few more seconds. Be able to fly, read minds. Just think how many projects could be finished early if we could read some minds. Okay, right, I'll close that one up and share the results. Okay. I hope everybody can see those. So, 24% would like to be invisible whenever they want. 6% would like superhuman strength. 6% would talk to the animals. 35% read minds. 29% be able to fly. Interesting. I don't know if Stephen, you can hear me, but any thoughts on the votes there?
I was going to vote for talk to the animals, Stuart. So I was in a minority there.
Oh.
Yeah.
Obviously, that's the softer side coming out there, Stephen.
Yeah. Well, I think we can get more animals to partake in the projects. We could increase our workforce, and increase productivity that way.
Fantastic. Yeah. Okay. Well, thanks for voting on that one. Let me just bring in the next one now, and this pertains to our session today. I'll launch that one now. Okay. Hope everybody can see that. Are you implementing blockchain within your organization? So please feel free to vote. Encouraging. Just sniffing around the edges, but no pilots. Okay, 12% are implementing at least one live project. Okay. Right. Just give that a couple more seconds. Thanks everybody that's voted so far. Okay, we've got some results. Let me share that. So 18% no intention of using it, 65% just sniffing around the edges but no pilot, 6% running at least one pilot to see what it's all about, 12% implementing it at least one live project. Any comments, Stephen, on that? Is it what you thought?
Roughly speaking, yeah, I was surprised to see so many people who are not considering using it. I guess part of our remit today is to try and convince that 18% to drop down into join the 65% below it.
Sure. Well, thanks everybody for voting on that one. That's interesting, and I'm sure Stephen can educate us onto exactly what what this is all about. So I'll just close that up now, and I'll move on to the next slide. Just bear with me a second. I've got a slide freeze. Seem to have that every week, but okay. So let me introduce Stephen. Stephen Smith. Stephen is a highly motivated and dedicated technical specialist with over 20 years experience in information management, along with technology and innovation implementation. Stephen is passionate about using design thinking to implement innovation or innovative digital transformation solutions that deliver measurable performance improvements. Stephen's experience within the industry has guided him in understanding how to evaluate the practical value of technology and how to implement it successfully within complex environments. I should also add that Stephen was previously a construction chair at Commit for a number of years, and Stephen contributed significantly to the progress and the leadership within Commit. So without further ado, I'll hand over to Stephen now, and Stephen will take us through his very interesting slide deck. So Stephen, just bear with me 1 second while I just hand you control. Okay, it's all yours.
Great, thank you, Stuart. So I think I'm on. I'll get started. So thank you, Stuart. So I want to talk to you today about a subject that I'm very passionate about, and perhaps some people say bordering on obsessed, which is about blockchain, and specifically how I think digital ledger technologies, of which blockchain is one type, can help us to deliver digital twins. For those movie fans out there who know Dr. Strangelove, I've given the presentation the alternative title of How I Learned to Stop Worrying About the Data Tsunami and Love Digital Ledger Technologies. So no presentation about technology implementation and construction would be complete without the mandatory productivity slide. You all must know that construction is lagging behind other sectors in productivity. Our average growth, as you can see, year on year has been about 1% compared to 2.8% for the global economy, and 3.6% for manufacturing worldwide. So if you look at that in terms of compounded growth, over time, we're lagging further and further behind other industries. Given that construction sector is about 13% of the global economic output, if construction productivity could match these overall productivity levels of the overall economy, we would improve by about $1.6 trillion every year. And if we could parallel the productivity of manufacturing, that could add an extra $2.2 trillion saving each year to the global economy. So this represents a huge opportunity, but it's also imperative because we're forecasting around 7.7 billion people living in cities by 2050, which means that we now need to construct an additional 13,000 buildings each and every year from now on just to keep up with demand. So I'm not going to try and argue today that digital ledger technologies are a panacea, that a silver bullet which can magically improve productivity on their own. However, an Autodesk and RICS industry survey from earlier this year highlighted 5 industrialized construction megatrends, many of which you probably recognize that are on the slide. What I do want to talk about today is how I believe that DLT needs to be part of our industry strategy to boost productivity. It is a foundational technology that can support these megatrends, and I was pleased to see Autodesk and RICS confirm this in their report. Specifically today, I want to talk about how I think DLT is complementary to three of these megatrends, and I'll speak about them in general terms, with big data, AI, and predictive analytics part of a data tsunami, IoT as part of the more general shift towards distributed computing, and finally automation. So the first theme is all about data, how we're currently being hit by a data tsunami. The blue line represents the number of devices worldwide that are PCs, and the three largest sources of data being generated now can all be broadly categorized as Internet of Things devices. By 2025, it's predicted that we will have over 400 billion devices transmitting data. These devices will be producing a huge amount of data, which we simply can't process and make sense of without big data analytics, AI, and predictive analytics, which will help industries, construction, and others see the signal for the noise. On the previous slide, we showed how construction has lagged in productivity over the past 20 years, during a time when we saw relatively small amounts of data in comparison to what we're dealing with today. So it's slightly scary to think that we're going to have to learn how to deal with much larger amounts of data moving forward. And the industry really needs to recognize this and ensure that we have the correct resources on our projects to manage data effectively, particularly as the world becomes more connected. So the distributed, as the amount of data in the world increases, the way in which we store data has also shifted. As the world's become more connected, the way in which we access and process data is becoming more distributed. This has been a quiet and somewhat hidden revolution, which many of you may not be so aware of. Distributed computing is a collection of independent computers that appear to the end user as a single coherent machine. For example, when you perform a web search on google.com, what really happens behind the hood is that Google's routing the query to distributed servers in different geographical locations to provide the search results as quickly as possible to you. Distributed computing really serves two important functions. Firstly, it's bringing the computer power physically closer to the end user to reduce latency. And secondly, the problem is being broken up into multiple chunks, with each chunk of a task being computed by a host of individual distributed computers. So distributed computing is designed to maximize efficiency of computing power, and is an approach that has been developed to help us cope with this ever-growing amount of data and our increased connectivity that I mentioned on the previous slide. The third important thread I want to discuss is automation. Since the dawn of the information age, our major advancements in productivity as a society have largely been because of automation. Automation being the ability to perform a process or procedure with minimal human intervention. For example, in the US between 1972 and 2010, the number of people employed in manufacturing has fallen from 17.5 million to 11.5 million. But during that time, manufacturing value has grown by 270%. And we tend to think of automation like the image shown on the slide, a computer talking directly to other computers. Of course, behind the scene, it is we require these computers to speak the same language. They need to exchange data over the same protocols and use the same codification. They need to be interoperable. Only by removing human intervention from a system can we expect to process and interpret the massive amounts of data being generated today. We can also only use distributed computing techniques to maximize efficiency through the use of automation. So to wrap those three threads together, distributed computing and automation together help us to process and make sense of the ever-increasing amount of data being generated by the Internet of Things. So if you bring all those three convergent themes together, you can build digital twins. The data tsunami generated from IoT and masses of sensors to help us understand the physical world, distributed computing to be able to process the data in near real time in close proximity to the physical thing that's being twinned, and automation to be able to connect all of those disparate computing systems together using common languages. These techniques are vital to be able to build digital twins, a realistic digital representation of assets, processes, and systems in the built environment. What makes it a twin is the data connection between the physical and the digital spaces. In this simplified drawing, the data flow is the link between the real world object and the digital representation, which is being continually updated using sensors. And these sensors in the physical space generate data that is used to establish the representation of the virtual space. The digital representation, in turn, is used for visualization, modeling, analysis, simulation, and further planning. The information flow going back is the feedback loop for decisions and changes in workflow that influence the control processes of the physical space. And this information link is often referred to as interventions. So I like to think of digital twins in terms of the Formula One. I mean, in F1, there's a staggering amount of data being generated. There's over 300 sensors on each car, generating more than 1.1 million data points per second. And that's from each car. And it could be argued that success in F1 today is as much a factor of the team's ability to manage their digital twin as it is about the skill of the driver. And the race is in many ways being driven by the digital twin, with complex computer models relaying optimal race strategies to the driver in real time during the race. Virtually speaking, the digital twin runs exactly the same race as the physical car, including road conditions, weather, and temperature. Such a system can help prevent costly and potentially life-threatening malfunctions using predictive analysis. So the F1 teams acknowledge that the digital twin is not perfect, but importantly, each time the car is raced, they are able to simulate and compare this versus the physical and tweak and improve the digital twin over time. So this is very powerful because it means that the longer the digital twin is running, the better the F1 cars become. And I think this is really the promise of digital twins for the built environment. It provides this continuous improvement feedback loop for our infrastructure, buildings, and assets. So F1 has learned to treat data as an asset. Construction and the built environment, I think, must also recognize digital assets such as data, algorithms, and digital twins as genuine assets, which have value and must be managed effectively and secured. In time, as data and digital assets become valued, data itself will be seen as infrastructure. So how does this all fit in with digital ledger technologies? I think the answer is that DLT is highly complementary to digital twins. They are designed to be fundamentally scalable to handle massive amounts of data, are fundamentally distributed so to realize the benefits of distributed computing, and are fundamentally automated to be able to connect systems together without human intervention to bring about productivity gains. In DLT world, this automation is mainly done through something called smart contracts, which I'll briefly mention later. So the characteristics of the DLT are very well suited to delivering digital twins, which, as I covered, also require scalability, distributed computing, and automation. So I've covered how I believe DLT as a technology is complementary to digital twins. I'm hoping during the panel that we can focus on some of the specific real-world applications. But before I wrap up, I wanted to quickly look at two of the main use cases where I think digital twins can support be supported by DLT. So firstly, going back to the RICS and Autodesk study I referred to earlier, one of their key recommendations was that we needed to adopt a product-centric approach to construction delivery. Each product forming part of the digital twin should be managed with a unique identifier, and appropriate data should be tagged against that identifier throughout the life of the product. Here we see a simple example of a life of a battery clamp, with each step showing data that needs to be stored, through the life of that asset. This idea, of course, is not new. I think the industry has been advocating this approach for many years. However, the industry has struggled to do so because of all the data is typically locked within different company systems. There is a lack of interconnectivity and a lack of trust between parties who are reluctant to share data. I think that DLT provides a unique opportunity to enable this product-centric approach, because it is possible to store the data independently of each party needing to contribute data to the digital twin. And the ledger can be an independent single source of truth that is also immutable, so that each party can trust that the data has not been tampered with. Access to the data can be secured with access controls for only approved persons to view. And this shared data can become an important data layer for digital twins that can be used to improve the physical built environment. So the second use case I quickly cover is how digital twins, through the use of smart contracts and automation, can help with digital twin delivery. A smart contract is a piece of computer code which is stored on the ledger and is automatically guaranteed to execute when specific input conditions are met. To understand a smart contract, you can think of it as a vending machine. When we insert money into a vending machine and select an item, the machine automatically dispenses the item and also returns any change. It also automatically records the number of items remaining in the machine and notifies the maintainer when items need replenishing. A smart contract works in a similar way. As an example, Philips was recently awarded a contract to provide lighting services at Schiphol Airport, with Philips designing, installing, and now maintaining and repairing the lighting system, and they are paid based on the quality of service they provide. This servitization model aligns with the approach the UK government would like to move with public tendering, paying for the outputs of a service rather than tendering based on the capital costs. So the IoT sensor network from the lighting system continuously records the lumen levels and consistency of lighting throughout the airport. If this data was provided as an input into a smart contract on a digital ledger, then this could automatically trigger the payments to Philips for the services they're providing based upon the agreed design requirements. No human intervention would be required to raise invoices, there'd be no intermediaries, and there'll be no delays in payment. This approach could be applied to any system or service within a building or facility where IoT sensor data was being installed as part of a digital twin. So I see in the future, hopefully, DLT will work together with IoT networks to facilitate digital twins that are made up of individually managed smart devices that communicate directly with each other, keeping track of how they're performing, how they interact with each other, and what state they're in, potentially leading to systems that are self-governing and maximize efficiency, for example, adjusting heating levels or lighting based upon a change in occupancy level. So before I wrap up, I want to quickly summarize the benefits I think blockchain brings to digital twins. And this was a list based on a study undertaken by IBM. Firstly, security. I have not mentioned security until now, but it's a big issue with IoT and digital twins, with more than 25% of enterprise attacks currently involving IoT devices that have failed to be secured or have been hacked. With IoT currently, it's a centralized model with all devices being authenticated through a cloud server, which means that there's a single point of failure, which becomes a honeypot for hackers who want to exploit and steal the data. If the IoT devices are managed on blockchain, then the central trust model is eliminated, and each device uses cryptography to verify its own identity without going through a central party. The data can also be encrypted on the chain, so sensitive data can be concealed from anyone spying on the network. So this basically eliminates one of the major problems we face with IoT and digital twin deployment. We touched upon trust. Blockchains are not owned or controlled by any central party, so they are inherently trustless. But we're seeing already that this is proving to be beneficial in other sectors, such as supply chain, where companies who are traditionally competing and have confrontational relationships are moving more towards cooperation, where it makes sense to share data and cooperate for the overall benefit of the industry. DLTs can provide a means to do this. Accelerating transactions, I mentioned also, by using smart contracts, we can reduce settlement times between parties and systems from days or weeks to near instantaneous, particularly when the inputs into the smart contract is digital, such as the servitization lighting example I provided. But finally, the main benefit has to come down to cost. Digital ledgers can help reduce costs by removing intermediaries. This needs to be balanced against the additional costs that come with implementing and maintaining a DLT solution above traditional databases. And DLT should only be used when there is a strong need for data to be managed in a distributed way. So just a quick recap, and I'll hand back. To summarize, our world is becoming increasingly connected, distributed, and automated. And the data tsunami and the advancement of big data techniques such as predictive analytics are accelerating our hunger for data and the importance data plays within our industry. As I've covered DLT can help to support the 5 industrialized megatrends that were identified by Rix and Autodesk, particularly big data, IoT, and automation. Digital ledger technologies are complementary to digital twins because they are fundamentally scalable, distributed, and automated. And finally, DLT can help to deliver digital twins by increasing security, building trust in our industry, accelerating transactions, and reducing costs. So thanks for listening. I hope you found that interesting and thought-provoking. I hope it leads to some questions from the panel, for the panel later. So I'll hand back to Stuart. Thank you, Stuart.
Thanks, Stephen.
Let me stop sharing.
Very interesting facts there. One question I've got, and I think you slightly touched on it, but on security, the issue of security, is that potentially a blocker and something that restricts anybody wanting to look any further, do you think? I mean, what I mean by that is there was if anybody follows Homeland on Netflix, there was something on a few weeks ago that I watched. I think it was an old series or an old episode, and somebody had tapped in to a pacemaker and manipulated the pacemaker of an individual. And I suppose it could be for anything really. That sort of thing's a little bit scary. I mean, obviously it's fictitious, but you know, that sort of technology, if somebody can come along and interfere, do you think that's a blocker?
Yeah, it's a huge problem right now. I think when we get the panel started, Michele is an expert with, he studied this area of IoT and security. But it is, as I said, Stuart, we're suddenly having billions of devices that are being managed that need to be secured, because they could either be hijacked and somebody could pretend to be a device and transmit data which is false, or you could steal the data because it's valuable. You may change the data to your own purpose and use. So with blockchains, the promise is that every endpoint device will be encrypted, and somebody could try and break into that device, but it would be very difficult, and they would only benefit from getting access to one device. They wouldn't actually be able to connect into a whole host of devices that are being managed centrally. Yeah, so I think it could bring huge benefits to solve that problem they have at the moment.
Yeah. Well, thanks for adding some perspective to that. Okay, so we're now going to introduce the panel. I'm going to ask Gavin and David to join. Michele's already in there. Hi guys, thanks very much for coming along today and participating, and thanks for your support in helping get this session together with Stephen. Stephen I've already introduced. I'm going to introduce, it goes from right to left here on my script sheet here. So I've got Gavin on the right hand side. What I'd like to do, guys, is if I can, you give a quick overview of yourself, if you wouldn't mind, starting with Gavin, and then we'll go to David. Is that okay?
Yeah, no problem. Can you hear me?
Yes, loud and clear.
Fantastic. Hello, everyone. My name's Gavin Johnson. I'm a lawyer for my sins, but I run what I call an X-Tech consultancy. So this is advising X-Techs, particularly in and around construction, engineering, and more broadly, the built environment, which is, as Stephen pointed out in his talk very well, it could be a real game changer for construction generally, particularly when you think that the built environment really does underpin everything we do. Whether you work in an office, well, somebody's built that office. If you're a banker and you do trading, well, somebody's built the infrastructure for you to do that trading on the digital infrastructure. How did you get to work this morning? Was it by car? Was it by train? Did you fly? Somebody's built all that. So built environment and any improvements we can make to it will really fundamentally change the way we live in the world around us.
Thank you, Gavin. David, over to you.
Hello, everyone. My name is David Ayeni. Glad to be on this panel with esteemed people here. I'll start by saying a bit about myself. So I'm a process engineer by background, so digital design is something I've been involved with through digital construction and information handover to owner operators for the last 2 decades. And I agree with everything Stephen has said. And the desire for outcomes that the digital ledger technologies would have provided then, back in the day when I started my career, are still the same now. So, you know, provenance, transparency, efficiency, effectiveness, especially when it comes to design requirements, their completeness and the verification of them when you get out into the construction job site. So, you know, it's something we've been wrangling with, trying to tackle for the last, you know, couple of decades that I've been in the industry. But I'm sure, you know, this problem has been you know, had before even I started in this industry. So it's an interesting topic and one that I'm following very closely. I work for a company called Digital Construction Works, and Digital Construction Works is an organization that actually is trying to help advance the industry from, you know, the laggard position that we are right now, doing all sorts of cool things with digital twin technology, digital twinning, and trying to really use the distributed ledger system to deliver blocks and mortar, pardon the pun for Steve and his company there, when deployed correctly with accurate and complete information requirements. So we are doing a lot of work in this space, and we're trying to fuse and help companies understand how the DLTs are very much complementary with the digital twins. So really happy to be part of this panel and looking forward to the discussion.
Thank you, David. If I can ask Michele now to jump in. I think you're muted.
Yeah,
there you go.
Now I'm not.
There you go.
I tried before, but I thought you controlled that. Happy afternoon to everybody and happy hour to everybody. My name is Michele. I'm very glad, happy to be part of this panel. I work for the IOTA Foundation. IOTA Foundation, it's one of this distributed ledger technology and provider of this technology. My background is mainly from Internet of Things and distributed ledger, of course. I'm working mainly as a technical analyst, try to bring innovation using distributed ledger and IOTA in particular in different sectors. I'm mainly focusing on supply chain as well as smart city, smart energies. So yeah, I'm very happy to join the discussion and give my overview on where distributed ledger, in particular the combination with Internet of Things can help solving some of the problems that this industry is facing. So before working for IOTA, I mainly focus on different other roles and try to understand also better the role of personal data and how to deal with personal data on a distributed ledger. And yeah, I'm happy to discuss this during the panel.
Thank you, Michele. Thank you very much. So I'm at the point now where I have some questions, and the first question I've got comes in from Sue Butcher. Thank you, Sue, for this one. What would be, I suppose I should really go back to what you said previous to that. Who would want to read everybody's mind? It would be disastrous. Thanks for that, Sue. I agree, it would be, particularly if they're thinking the wrong thing and doesn't align with what your thoughts were. So yeah, thank you for that. So your next question is on topic. What would be the difference between data and information on your graphic of digital twins? Conventionally, data is not organized or structured, but information is. Stephen, can I ask that of you? Oh, you're muted, Stephen.
Excuse me. Can you hear me now?
Yes, there we are.
Yes, I mean, well, a distributed ledger really is just a place to store data, similar to a database, right? So you need to be able to analyze that data to turn it from data to information. So I think we'd look at it in the same way that you would look at any other database. It's used in combination with other systems, other techniques like analytics and querying to sort of make use of the data. Yeah, so I think some of the data that's stored on a ledger would be classed as information if it's being sort of processed prior to it arriving on the ledger. Within the DLT space, there's this concept called an oracle, where when the information is being pulled into the distributed ledger, it's going through a service, an oracle, which is sort of checking the validity of that information. So if you could think of a good example, a simple one is a weather station, so that you can trust that that information is correct. And I guess it goes back to Sue's first comment as well, is, you know, why would everyone want to read someone's mind, particularly if it's not correct? So you have this idea of oracles, which are very critical to distributed ledgers, that you need to be able to trust the information that's stored on there, that is immutable and is going to be there for everyone to read. So I think in that's, you know, for data like that, you could consider it to be information, in that it's been validated and processed prior to it arriving.
Okay, good. Thank you for that. So I hope that answers your question, and I can see your hand up again. Yeah, if that answers your question, Sue, that's great. Please do keep the questions coming in. As I mentioned earlier, you've got a couple of options in the questions box, or just raise your hand. Okay, so I've got another question. This comes in from Richard Nelson. Thank you, Richard. If we had blockchain stroke DLT materials records during construction and a digital twin in place during operation, would the Grenfell Tower tragedy have been avoided? Who wants to take that one? Gavin, did you put your hand up then? You did.
I think it's
Hang
muted.
on. You're muted. Let me unmute you. There you go.
Oh, there we go.
You're free. You're free now. Go on.
It's a tricky subject. Fire is at the forefront of every designer's mind, certainly when new buildings are being built, and it continues to be so post Grenfell, but there is more attention on it, certainly. And I think, if I remember correctly, that the fundamental problem at Grenfell was the type of cladding that went on and hadn't been properly tested in very, very broad terms. But I also suspect there was probably, let's say, managerial type failures, probably on the part of the oversight by the council. I don't think that's particularly contentious to say, but also probably within the supply chain, there's a lack of knowledge around the materials being used, and probably improper testing that have been applied. Now, I tread carefully because obviously this is all ongoing, and as a lawyer, I don't want to speculate. Would better of information have prevented Grenfell? Probably not, sadly to say, because it's not necessarily it's not necessarily the information that's been acquired, it's the process that has been applied. And I think the failures were process failures, as in the proper testing hadn't been done. Would that have been caught? I don't know. I think that's highly speculative and very difficult to say. And one can only hope that lessons are learned when it comes to appropriate testing, and that proper oversight is given to that testing, and it really comes down to the processes applied. Now, if we can design better processes and implement better processes, then yes, of course, we should avoid such catastrophic incidents in future. But would they have prevented Grenfell? No, and who's to say if it wasn't Grenfell, it wouldn't have been some other issue with some other cladding on another building. I think I remember the MP, who's I think is now Mayor of Greater Manchester. He came on and he instructed a review of all the buildings that potentially had cladding issues in the Greater Manchester area. And you know, I don't know how many years on we are now, but that's still underway. So it's not like the response or the political will it appears to be there to deal with it either, which should be even more concerning. There's a real lessons haven't been learned feeling, to my mind anyway.
Sure. Does anybody else want to come in on that?
Yeah, I can say something. I would say no, and again, probably don't remember very well what was the cause why it wasn't possible to react in time. But I would say that if data didn't exist, using or not distributed ledger wouldn't have changed the situation. But if some of the data would have existed, at least probably putting this data on a distributed ledger, first of all, will allow with a digital twin to probably access this data more easily and faster on demand when it's needed, when there is an alarm trigger. So I would say that in this case, most of this data lives in isolation, and when there is time to propagate alarm, alert, all these systems need to be interconnected, and keep all these systems interconnected is much more difficult than having a system that is already there, exists, and provide, let's say, a trusted layer where this information can be shared and everybody can go and read it, which is what a distributed ledger can do. On the other hand, what probably could have solved the problem and using distributed ledger or maybe prevent in future similar problems, the transparency on data that distributed ledger can give. So if you think about certification of equipment or environment buildings, or a fire detector or things like this goes on a distributed ledger, there is the double effect that it's possible to know very easy when there is there is time for reviewing this and updating. And on the other hand, there is who is producing this information. There is a bit more, let's say, need to be careful that this information can be accessed by other party and be more transparent in doing the job right. So if you have to review equipment every year, and you know that there is a third party that can see this because it's shared on a ledger, then you are more more keen to do it, or you have more pressure on doing that. So all this kind of transparency that distributed ledger can bring, I think, set of best practice that everybody in the industry, in the construction industry, start to follow because of being observed by others. So without saying that it's public domain, but again, transparency means that somebody can require access, and these data are on the ledger, are trusted because there are timestamps that says when this data goes on the ledger. So knowing that you are open or exposed to that kind of request at any point in time makes you do things better. So in that way, probably distributed ledger can help to have a paradigm shift, knowing that the data are not safe in my own environment, but can be requested and accessed by anybody, and anybody will see what I've done in the past. So I cannot go back, revert the history, will make me think twice on what I'm doing with my process and how I generate my data. So I would say that, yeah, but wouldn't solve the problem back then, but probably going forward will establish best practice for the industry that might help removing this issue or preventing this issue in the future.
Okay, thanks, Michele. Yeah, great. I'm going to move on to the next question, if that's okay. From Steve Sims. Thanks, Steve, for the question. So the question is, do you consider DLT the ultimate data governance from MDM data gravity? Who wants to take that? David, is that for you? Can I unmute you? There you are. Yeah.
Can you repeat the question, please?
Yes, I can. Do you consider DLT the ultimate data governance from MDM data gravity?
Okay, so we're talking master data management. Well, I would like to answer the question in this way. I think in the end, when you deploy a DLT, there are processes in place, data governance processes in place, and I think as an underlying technology, yes, a DLT can help with your master data management, but I ultimately believe that the way you structure your environment has to have good, strong governance. And if you want to have a robust layer of transparency, everything we know the blockchain DLT platforms can provide, yes, but to say, is it the ultimate? I don't know. I think it's horses for courses. It depends on what type of organization you run, the scale of your organization. But can it play an integral role? Absolutely. It's probably one of the most robust foundations that we've seen with all the characteristics. But I think, again, horses for courses. I wouldn't ask, mom and pop shop to try and implement or use a DLT as the foundation of the MDM strategy. But if you are a mega corporation and you want to implement a DLT and integrate that with your data governance strategy, then absolutely. So I think it's horses for courses and what you're trying to achieve. That's what I would say.
Okay, thanks, David. Anybody else want to contribute to that one before I go on to the next question? I've got several more questions here. Gavin, jump in. Yeah,
we might cover this in a later question anyway. But I agree with David. It's part of a solution. It's not the solution. And I think ultimately you've got to look at what a DLT and what a blockchain is. Obviously, you can have one without the other. But all it's doing is like any ledger. It's recording the existence of a transaction. It's not necessarily recording the okay, it depends what goes in the ledger, but the underlying transfer of value. And so yes, can you validate or authenticate the existence of a data in a certain way at a certain point in time? Yes, but do you do? I'm not sure. I agree that you can. It becomes the point of data governance, and I think, as David, I think quite rightly said, it's part of a much wider solution for larger organisations, certainly. Okay,
thank you for that. Okay, the next question I've got is from Fran Raybook. Thanks, Fran. I question the idea that IoT and DLT will interact, or interact rather. DLT is focused on transaction/ledger, mostly static data. IoT is real-time, streaming and large. The volume flow of IoT is not a good fit for DLT. Response time from IoT needs to be close to real-time. IoT is mainly numeric in nature, and DLT mostly text, transactional information, documents. For IoT-centric folks, do you really see DLT as necessary for IoT to advance? Does DLT need or serve well IoT? Stephen, can I ask you on that one? Would that be good for you?
I would like to hand that over to Michele. I think it's a question I think the question's been planted for him to answer that. So.
Is that right? Okay. Thanks to Fran. Oh, you need unmuting, Michele. Yeah.
Sorry. Yeah, I don't want to talk too much about the company, the organization I work for, and the technology that we develop. Otherwise, it looks like advertisement. But I will say that first of all, we need to distinguish between blockchain and blockchains, or blockchain and DLT. So not all the blockchains are the same. Not all the DLTs are the same. So some might share the same properties, but probably they don't share the same way of working, the same inefficiency. So I know it's true. We start with blockchain, Ethereum, and Bitcoin that are mainly focused on value transfer or smart contract execution of small, simple instructions that actually lead to the transfer of funding and monetary value. But there have been progress in that, and there have been other distributed ledger technology that try to overcome this issue. One of these is IOTA, the technology and the foundation for which I work. That basically has actually this target. They want of creating a distributed ledger that actually can scale with the amount of data that IoT device can provide and the response time that is required for an IoT device to provide. But it's try to bring another important piece of the puzzle that otherwise will make this technology deployable in future. That depending on the scale of IoT device, we cannot expect to pay for transaction to store data like it's happening with the technology, probably the blockchain technology that the question is referring to. So we need to have a ledger that is able to work without being linked to monetary value, to cryptocurrency, like it happened for many other cases where there is an incentive that is purely monetary to give the consensus that the network requires. So all this is possible. The technology exists. Of course, there are still limitations that will required to adapt with the changing of IoT and the evolution of IoT. But it's also true that one already way to secure IoT data with let's say with distributed ledger is not to put any single data that comes from IoT device on the distributed ledger and pretending that one data goes in and the other data goes out on the other end at the same speed. But again, there is a lack of trust in sharing data across centralized system that never tell us if this data that we are sharing are actually the real data, or these data are not being changed in transit and things like this. So one other approach is that we can minimize the number of data that goes on the distributed ledger, and this data can perhaps be just what is called fingerprint of the data, what is called hash of the data. So basically you take the amount of data, you just store a mathematical function that expresses this data in the ledger, in the distributed ledger, in a way that from there onwards is immutable, cannot be changed anymore. But this gives the value that once you read the data set on the other side, you can always compare with what is on the blockchain, which is a very small portion of that data set. You can always trust that this data hasn't changed. So this already brings a lot of improvement, a lot of way to secure even more the trustworthiness on the IoT data. So there are different ways. I wouldn't say that technology is not ready, so I might have to contradict to this affirmation in the question. So yeah.
Okay, thank you for that. I hope that answers the question, Fran. The next question, I think,
IOTA, for instance, and it can be a start for learning a bit more on how IoT, distributed ledger can scale into IoT.
Sure. I think this next question overlaps a little bit. Thanks to Manuel Sukendro for this one. The question for DLT versus a centralized system goes like this. I have difficulty to see the benefit of DLT compared to centralized or a centralized system in my case. Let's say I'm the owner of a power plant, and in my building, in the building of my plant's digital twin, I can just force the suppliers and contractors to submit their relevant data or their services or products in my centralized system. So I guess the question is, what are the benefits when you compare one with the other? But for the erection of a large infrastructure project.
I'll take the first stab at this, guys, if you don't mind.
Sure.
So Stephen touched on this before. You know, Steve and I have a similar background for our sins, but he touched on this before. So having a centralized database versus a distributed one, but specific to DLTs. Now, yes, as the gentleman mentioned, you can have information from your contractors, your vendors, from the supply chain being pushed using certain schemas into a centralized database. But the point is, how do you understand the provenance or accuracy of that data? Is the data being massaged and being sent to you on a weekly, monthly basis, daily as required? How do you know where that information is coming from? How do you verify and validate that information isn't just to keep you happy, and then when the chips are down and the rubber hits the road, things fall apart? So the whole point of having a distributed ledger technology implementation is that you can have insights real time into, if you want, into the data, the correctness and the completeness of that data, and you can ask questions. Why is this like this? You don't have to wait till it's submitted. You have access as the owner, based on the way you set up the system, to know whether the information is as needed. And you can, and as Steve said, with smart contract implementation, it can be automated. So I challenge the power plants that think that centralizing this information is better than distributed, because it's just going to perpetuate the issue that I've been faced for 20 years and those before me have seen for longer.
Yeah.
Okay, thanks, David. Michele, yeah, jump in, yeah.
Yeah, I would say there could be another element. I would say one, it's ownership of the data. Me as a supplier, what's happened when I put all my data into another party centralized cloud? So do I lose ownership of this data? And secondly, is if I become supplier of another party, do I need to maybe some of the data duplicate this data or recreate this data? So with distributed ledger, there is more, let's say, ownership, let's say more, the data source is also owner of the data. So you put the data on the ledger and you decide who get access to your data on demand. So if there is now a central plant that needs access to my specific data from my technology, then it can go there and then can read. They can add another person. So I don't need to, let's say, go and integrate from a supplier point of view with many different centralized systems. It also create vendor lock-in, because I would say every different system has different technology, reduce the type of scalability, and again doesn't bring that footprint on the data that gives the provenance of the data, where this data comes from, and gives also the let's say the trust from the supplier that when this data goes into the to the cloud, if there is something coming out that is consequences of the data that's been used, I provide, I know which data is being used, for instance, for some machine learning or AI, automated intelligence, artificial intelligence process. So I can control this flow. When my data as a supplier goes into a centralized cloud, I lost completely track on how this data is used, what's happened to this data after they're there. If decision coming out of this data involve me, I always can question, did you use the right data, or did the data change in transit, or something like this? So, and this create friction in the industry that distributed ledger can remove, and can definitely deliver more efficiency.
Okay, thanks, Stephen. Yeah.
Just to add a bit of a twist to that, I agree with everything that Michele and David were saying. I think that if usually on these large projects, like a power plant project, you're going to have very large organizations working on that project, and each of them have their own internal systems that they've invested heavily in, millions of pounds or dollars probably. And I think ideally the best solution would be that each of those individual organizations could continue to use their own internal systems, and then have some way in which the data they need to share with others for the purpose of the project could be integrated from one internal system to another internal system. So if you think about the efficiencies that were brought about through ERP systems within an organization, there was a huge efficiency gain that happened when we were able to integrate our own payroll with purchase ordering and within an organization. I think blockchain has an ability to bring those efficiencies kind of across organizational boundaries. So there is a different approach to using blockchains, whereby the blockchain just acts as a kind of a baselining or an integration layer between these systems, and potentially you can actually, you basically hold and maintain your information within your own systems, and use the blockchain as a means to ensure that the data between the systems are balanced and baselined, which I think would allow every organization to own and manage their own data, as Michele was saying, to continue to use all the processes they do internally, to not duplicate data, but to share that data and to baseline it when needed. So I think that's an approach that we're going to see come over the next 5 or 10 years with blockchain, or with DLT, I should say. Okay, great. Thanks for that. Listen, we've done the hour now, so this is not the end of the session, by the way, because we've still got several more questions to go at. I do need to keep time to the hour. Those that signed up for the hour that need to get off, then that's fine. We have got an extended session for the next half an hour, or next 26 minutes. Let me just finish off the rest of the slides if I can. 1 second. So yeah, we've got more opportunity for more questions. So hold on. I need to just say thank you to everybody. Myself, Jerry, and Ian. Jerry and Ian couldn't make it today, sadly, but thanks to our panelists. Thanks to Stephen, the presenter, Gavin, David, and Michele, and everybody that came in. Thanks for the questions. We have another session, not next week, but the week after. We're now going to every 2 weeks. I think as I've engaged with one or two people, I'll explain the reason for that. Every 2 weeks. I'd like to just mention, I've sent immediately this webinar finishes, there's a survey going out asking which day of the week and which time best suits. A lot of people say just leave it as it is, Friday at 3:30. We know when it is, we can come and go as we please.
A lot of interesting subjects. Interestingly, we didn't do a session last week, and I got so many calls saying I haven't got the link. Please send it to me, but of course we've not set one up, so apologies for that. We will have them for every 2 weeks from here on. So the other question I keep getting asked, and fantastic, they are asking me loads of questions. I'll come back to that in a second. Is this one. The recordings are available on the website. If you tune into the homepage, they're all on the front page. If you can just click on one of those previous sessions, we tried to highlight with a title which ones they are. Let me just go back. Yeah, I need to just very quickly thank our sponsors, O2 Business and Rebim. As I said at the beginning, we couldn't do this without them, so thanks for the continued support. And okay, so we're in the more questions session. A request I got from one of the attendees last week or the week before last said, rather than show the oldest pub in England, can we possibly have the oldest pub in Scotland? So there it is. It's in Ayrshire for those that are interested. So thanks for sticking with us on that. Right, I need to just come back to the questions. We have another question from Fran. Thanks, Fran, for this. I assume everybody's okay just at the moment, but the next question is related to Fran's previous question, and again, I'm going to aim this at Michele. Consider IoT as not moving to a single centric point, and in brackets, Fran says, for hacking, but rather is quickly moving to smart edge devices and mesh networks. Michele, is that okay for you? Yeah, you let me unmute you. There we are.
Yeah.
You should be unmuted. There you go.
Yeah, I am not sure I captured the question, but I will try to give my interpretation. So let's say that paradigm now shift and the IoT device don't go anymore sending their data to a central cloud, but mainly focusing on edge cloud. So it's actually what we call data dense edge environment. So yes, and the question probably, I assume, do you think, or I think that distributed ledger can still play a role in that kind of scenario? I would say yes. There are different ways again on the way I see distributed ledger can play a role. For instance, one of the way that, and the problem that I see in this case now, focusing on edge environment and focusing also on data that device, IoT device that might move from one edge environment to another edge environment about this mobility. So one of the problems that I see there, it's how we trust the authenticity of this device and the data that generate, how we trust the integrity of the data that comes into the ledger. This device, for instance, if you think about our smartwatch, health sensor, or other kind of sensor, if you think about maybe the construction environment, if you think about protecting the health of workers and things like this in different sites with different edge cloud technology. So I think one way distributed ledger definitely can play a role is in identifying all these devices. And again, if you want to move things at the edge, you think that this device moves from one edge to another, an edge cloud to another, you cannot rely on a centralized way to identify device. So there are distributed ledger technologies that provide decentralized identity management for device. So that's one way that allow this way of securing the data, securing the source of the data in environment that doesn't need, necessarily have to connect each other, different edge doesn't need to connect each other, but having this underlying, let's say, the identity system that run on a distributed ledger can create the glue across these different environments. So I see that even if you don't talk about centralization versus distributed and distributed ledger versus cloud, but edge device complemented by distributed ledger technology, still see a lot of interaction and way for them to work together. One is that it's decentralized identity management for IoT device.
Okay, thanks, Michele. I hope, Fran, that answers your question. Maybe just give me a thumbs up if that does. Okay, so I've got one other question here on the floor, and this is from Riaz Hassan. What is the difference between, I think you may have touched on this already actually, but what is the difference between having a distributed ledger and more conventional integration mechanisms where data is being passed from one solution component to another through, for example, a middleware integration layer? Who wants to take that one? Stephen, is that for you, or is that Michele? That's back to you, I think, again, isn't it? You're muted. Let me unmute you. Hang on. There you go. Oh no, you're muted again. No.
Yeah, sorry, we are doing at the same time. I don't know if maybe Stephen want to take and say something else. I would say in my view, it's still a matter of efficiency and avoid vendor lock-in. So of course it's possible to do this, but why to have a one point-to-point integration instead of like Stephen said before, thinking that there is this infrastructure that sits above or below, depending on the way you see all the other system, and again use, let's say, standardized interface to push data into this let's say bus that brings few more elements. So once the data is on this bus are immutable, so everybody's accountable for the information brings to the bus, this communication bus. So everybody, in case of problem, can be identify where the source of problem comes from. So this in general create a better data curation. So you are forced to know what you are putting into this bus sharing information, because you know that this cannot change anymore. So all the data are probably a better quality. On the other hand, again, you retain control on the data. So you don't say that your data leave your platform and goes in somebody else's platform. You also lose the value associated to this data, because then a third party can reuse the data without you being aware of the way they're using. So if you put on a distributed ledger, you control the access of this data for whose interest. You can always remove access in a much easier way than say, I stop sending you data, because those data are already, some of them in the system. So I think there is some element that brings more efficiency and added value of, especially this provenance, where data come from. So no repudiability of the data that I share, and so on and so forth, that definitely create better way to manage this process when issue happen, because as long we're sharing data and everybody's happy, everything is fine. In better with direct integration, it creates more work, but it still work. It's still good. But the problem that distributed ledger also can help solve and makes better process around the solution of this is when issue comes, and when we start to question about the quality of data that I receive, we actually inject this data into my system. So having this traceability and provenance guaranteed by a ledger that somehow is independent to what's happening in different systems, I think brings efficiency when we have to solve this kind of issue. So we always have to look both ways. So once we are happy with the data, and what's happened if we start to be happy with the data that we are sharing.
Okay, thanks, Michele. Stephen, one?
Yeah, I'll add some thoughts to that. So
yeah,
I think Michele was sort of hit the nail on the head when he spoke about a digital ledger as being this always-on infrastructure. That's how I look at it. So whereas, you know, if you think back to when the sort of internet was growing and companies created intranets and they managed their data within their own sort of siloed you know, communication systems, and eventually we learned to trust the internet, and the security around internet was such that we knew that we could share data on that always on infrastructure in a secure way. And over time, of course, 2 decades later, there's been a lot of development done to create sort of tools and applications where it makes the fact that we share all that data on this one intranet much more efficient. You know, we can plug in automation tools, we can borrow code, we can connect systems and applications together. We can reuse code, right, very effectively. So I think we've seen huge efficiencies come from the fact that we broke down those silos. And I see conceptually blockchain and digital ledger to be very similar, and that, or decentralized ledger systems to be similar in that sense. And I think even though we have a number of different technologies being developed, IOTA, Ethereum, etc., that eventually there will be interoperability between those different blockchains. There'll be sort of inter-blockchain communication, and you will benefit from sharing your data through that layer, that always-on infrastructure, rather than building a sort of end-to-end connection between systems. You would use this shared infrastructure. So I think it's going to take some time, and there are lots of issues to solve to get there, but I think that's the future that we're heading towards. Sure.
Okay, well, thank you for that. I have a question here, and I was going to aim this at Gavin first, but Gavin's dropped off. The question is around the disputes and litigation. Construction does suffer from those, unfortunately, and it continues. But how can blockchain and in particular smart contracts help this? Who wants to take that first? I would say I was going to aim that at Gavin, being a solicitor, but Stephen, do you want to, or Michele? I'm happy to take anybody first.
I can start it off. I think that this is an area where there's a lot of investigation happening currently. Smart contracts, people often say, are neither smart nor contracts, in that you know, they do provide a way to automate, and you can sort of guarantee the execution of something based upon the rules that are in the smart contract. So, but you know, potentially, you know, the theory behind it is that you can put these contracts on a open ledger, so that all the parties involved in a project will be very clear. It's very transparent as to what they're signing up to, and then when it comes to them being paid, or you know, a process to be executed, it's going to happen in an automated way. Nobody's going to sort of just prevent it from happening. Nobody's going to prevent it, you know, is going to delay a payment, etc. So in sort of theory, it sounds like a very you know, like something that could be highly advantageous, but of course, you know, contracts by nature are there's a lot of sort of human interpretation that takes place when most contracts are being executed. So I think people are realizing now that it's not quite as straightforward as being able to turn these into code and letting them loose on a ledger. But I think where you have you know, processes that can be fully automated, thinking back to the servitization thing I mentioned in the presentation, where you've got an IoT device that's maybe supposed to perform to a certain level of efficiency, and then that can be measured through a sensor, that can be pushed into a smart contract, and then a payment could take place in an automated way. It's that I think is going to reduce the amount of you know, disputes that you have in certain areas. So I think there are sort of these low-hanging fruit where we can start to automate and put smart contracts in place where the human interpretation side of contracting isn't required, and then the efficiencies can come, and I think some disputes can be removed through that, but I don't think it's appropriate in all circumstances.
Okay, Michele, do you want to add to that at all?
Not much to add. I fully agree with what Stephen said, that yes, smart contracts are sometimes overestimated tool because they're still quite dumb. They cannot do too many things, and verifying too many conditions. Definitely are nowhere near to what legal contract put in place. But again, combination of them and some element that can be automated, can be used in a smart contract, becomes very powerful with the immutability and provenance of the data that fit the smart contracts. Blockchain and distributed ledger, underlying ledger can give. So this definitely we reduce much more litigation on how actually a decision has been taken if the data that are part of this decision can be traced back and can be visible to all the involved parties, so without creating further disagreement. So I think that element, I keep stressing the element that as long that the provenance of the data becomes more important on the actual execution of the contract, that can come as a smart contract or can come by, again, a delegated third party that doesn't need to be more trusted anymore than before, because some of the data is reasoning on are immutable, and you can see who is actually contributing different element to the contract. So I would say that yeah, for real smart contract to be fully automated and decentralized and cover all the different situations that might happen, especially in the construction industry, we'll have to wait. But starting to have a layer of traceable and trusted information that will be used to take decision for this contract, I think it's already a good use of blockchain distributed technology.
Sure. Okay, well, thank you for that. I've just got a couple of more things here to cover. Sue was on the call, but she's now left. But she asked the question about the Centre for Digital Built Britain Digital Twin Hub. She's only just found out about it, but she said, "Has anybody joined it yet? Hands up." I wasn't aware of it, but I'm not surprised there's one being formed. But have you seen it at all? Do you know what it's? We know what it's about, but I'm not sure who's involved. No, useful or not? Potentially.
Yeah, I haven't seen that hub, Stuart.
No. Okay. All right. Okay. So I've got one other thing that I just want to ask here, and this is the benefits of using, or the benefits and challenges of using digital ledger technology. It was a question that we pre-formed here. I think you've probably answered it in a roundabout way, but where I'm going with this is a specific real-world application for blockchain. We've already discussed a couple already, but if we think about the infrastructure market, and I'm talking about capital build infrastructure that we've got in the UK, could you think about an application that would be of benefit to that particular area of our, for our industry? Stephen.
So one of the solutions that I'm working on at the moment is in the health and safety space, which is very applicable, I think, for infrastructure plus buildings, and it's the idea that you can have ownership of the data being held by the worker themselves through what's known as self-sovereign or self-sovereignty. So the way that this is going to work is that a worker will have their own identity, which is centrally managed on the blockchain, and we're looking to connect this in with the different certified construction organizations for getting certification and training and things like that, so that it will be a record of your qualifications and your experience. And as you work on site, you'll be gaining experience, and that's going to get recorded, and you'll be able to take that record with you as you move from project to project and from organization to organization. But I think the really powerful thing is that the worker will be able to manage their data and have control of it, and to choose how they share it with other parties, potentially monetize the value of that data also. So it's moving it away from this approach we have today with data where 5 or 6 companies, Google and Facebook and others, monetize data that is of us as users, to a point where we manage it ourselves. So yeah, that's one application that we hope to do things like bring about sort of a gamification of this as well. So if I think one of the things, if you can engage workers in a similar way to if you use things like Strava or Fitbit, and you're encouraged to perform better as a runner because you're getting badges or you're competing against others. We're looking to bring in these types of things into the worker health and safety as well, to try and encourage better health and safety performance on site. So that's one example of another specific use case that we're working on.
Yeah, that's a good one. That's a good one. That's one that I think many can associate with. Michaela, you got any thoughts on that to add, just as a final? Oh, you're on mute again.
Yeah, probably. Yeah, I don't have direct experience with the construction, but I'm responsible for the innovation that distributed ledger can bring in projects. So European project across different countries that actually focusing on the mining industry and supply chain, and probably share some of the element with the construction environment. The fact that there are workers there, the health and safety of these workers need to be protected, and there is always disposal of material that is not used and these sort of things. And there is also bad opinion of the public on how the mine in this case is working according to some environment regulation and things like this. So in that case, we are using the distributed ledger to put some of the data that express the all overall environment of a mine and compliance to some noise level requirement, pollution level requirement, all these sort of things on a distributed ledger that is accessible by the public, by the end user. So end user can gain more trust that actually things are happening in the way they should. So they don't need to trust anymore mine operator that shares some of the data saying that my mine is conformant to some regulation without actually the possibility to trust this data from the source, from the time they are created and put on the ledger, so nobody can tamper with this data anymore. So that's one way we are, for instance, using the ledger in an industry that is similar. So if you think about also disposing of material that is not used is disposed according to the rule and the regulation. If you create a certificate, passport of this material, you store this on the ledger, then it forces you to dispose this material according to the rules, because every time this is not found to be done in the proper way, everybody can track this back to you. So this creates a bit of best practice and better management of this working sites, construction site, can be mine, can be everything. So I think that's one way the ledger can bring innovation and especially open up the transparency of the process to a public that sits around the area. So whether it's a mine or whether it's a construction site next to my door, and yeah, I don't know what they're doing, if it's creating pollution, creating noise, or things like this. So that's one of the ways we are using this.
Okay, thank you. Listen, we've got 1 minute left. Just to sum up, Stephen, closing comments?
Yeah, I think Michele's example was very applicable to construction. When you think about how the last big projects I was on, Crossrail, we're very much on government projects trying to find ways in which we can share information on how projects are performing with the public, to show where the tax dollars are being spent, and to ensure that we're complying with environmental regulations and consents and things. I think the industry is pushing in that direction to try and be more transparent. And I guess a summary note would be to say that blockchains and DLT are by definition transparency layers. So there are, I think, many opportunities where we can start to put data onto these chains, where we can share them in an open and transparent way, and just to bring more accountability into our industry.
Okay, good. Well, thank you very much for that. Anything to finally add, Michele, before we close down for the evening?
Yeah, no, I would say that it's good to know and see that there are interesting challenging in this sector that I think distributed ledger can play a role in solving, and I strongly believe that it can. And I don't disagree with the fact that we have to carefully understand in which way to use distributed ledger. Like Stephen said before, it just complements of a solution. It's not the solution, and that's something that we have to keep in mind. And as well, we need to know that again, there are some limitation in the different distributed ledger technology we can use. So we need to be carefully match requirement to the best technology that is out there and identify and find this. So we have to do this process and follow this process. But I think there are interesting challenge ahead that distributed ledger can help to solve and bring innovation in the construction.
Okay. Well, thank you very much. Thanks, guys. Thanks for preparing the session, Stephen, and delivering. Thanks, Michele, for being on the panel. Thanks also to Gavin and David. I will pass on my thanks personally afterwards. To those that stayed on in extra time, we've recorded this and we'll post it on the website, and you'll also get a link to it as well afterwards. One other thing is, and I said this before, there is a survey. It'll take you less than a minute to complete. If you can help us with that, be much obliged. We'll see you in 2 weeks' time. But thanks again, guys. Great session. Lots of really interesting questions. Hopefully, it's educated a few people who are maybe a little bit misunderstood on what the session was. But great. Really appreciate it. It was well presented, and I think looking at the questions, it was well understood. So. Brilliant. So all that's left now is wish you all a nice weekend, and we'll see you again soon.
Thank you.
Thank you very much. Thank you. Have a nice weekend.
And you. Bye-bye.